What's happening, guys? Let's get going on this simplifying rational exponents as requested by one of my former students. So simplify, your answer should contain only positive exponents with no fractional exponents in the denominator. So no negatives allowed, no fractional exponents in the denominator. That's all we're going to be doing. We're basically going to be following along some pretty basic rules. For the most part, all we're going to have to do is add, subtract, multiply, divide. There's not going to be anything else really with it. Anytime you're going to have a problem where everything is in the numerator, you're going to add the exponents of your like terms. So for this instance, on this question, what we're really doing is we are simply going to be adding our -1/3 plus 3 over 2. If you are someone who's able to do that in your head, great. If you want to learn how to be able to do it in your head, I'm going to show you right now. You go ahead and do this number here multiplied by the number up at the left. So that's going to get you -2. So you again multiply it along the diagonal. You could also do the 3 times the 3, and that's going to get you the 9. And then on the bottom, you multiply the 2. I'll repeat that process. We multiplied the -1 times the 2 to get -2. We did the 3 times the 3 to get 9. We did a plus in between because we're adding the two things, and we are dividing by the 3 times 2. This right here is our added. -2 plus 9 is 7 over 6. And that's basically our final answer. We have added the exponents correctly. Don't forget the 4 is still there. 4x to the 7 over 6. Now, I'm not going to show that work on most of these questions because you have a beautiful calculator that'll do the work for you. There are two ways to get to an angle, to a fraction on your calculator. For your calculators at school, the ones that are yellow, you can hit alpha x, but you can see that doesn't work on this calculator because it's old. But the alpha x doesn't work on this one. On this calculator, you have to hit alpha y equals enter, and that'll get you a fraction. But if you simply type in that -1 over 3, and then I add that to the 3 over 2 there, the alpha y equals enter 3 over 2, you can see, sure enough, it gets that 7 over 6 as promised. So point is you're allowed to use your calculator. Just use your calculator if you want to, or do it by hand. I don't really care either way. Up to you. There's our final answer to the first one. Question number 2 is very, very similar, except for the fact that we have two different letters here. So first, the y's are extraordinarily easy. Remember, there's an invisible little 1 here, and anytime you're multiplying like terms, you add the exponents. So we're having a 1 plus 2 is going to give you 3. But another new rule for us, if we have a negative in the numerator, it's the same thing as a positive in the denominator. So a negative up there is going to become a positive on the bottom, and there we go. Anyone who likes like notes on this, the two rules that I've used so far, I've used the fact that I've used what's called the addition rule, or the exponents like term multiplying rule. If I have x to the a multiplied by x to the b, that is x to the a plus b. We call that, again, whatever, exponent addition rule, whatever you want to call it. I don't know what you want to call it. But if you multiply like terms, you add the exponents that we just did with the y's. And then the other one that we just used is the fact that if we have x to the -a, that's the same thing as 1 over x to the positive a. This is always going to be true, and the vice versa is true as well. If I have x to the positive a, that's the same thing as 1 over x to the -a. And so basically, you're allowed to flip-flop them whenever you feel like. Anything that is positive moves to the bottom, becomes a negative, and vice versa. Continuing on over here to question number 3. This one, I don't think there's much to say. You have a v on the top, a v on the bottom, 1 minus 1. Anytime you're dividing two things, if I have like x to the a divided by x to the b, that's always going to be x to the a minus b. So in this case, we have 1 minus 1, which is 0. So it's kind of like there's a v to the 0, but v to the 0 doesn't need to be written because anything to the 0 power is 1. You might have also just said, but don't the v's just cancel out? Yeah, sure. You want to call the v's cancel out? That's fine. Whatever. I don't care. Just say whatever you want. That's a 1/3. Done. Moving on. In this question, the 3's cancel out. Okay, so the 3's are gone. There are no 3's in front. 3 divided by 3 is nothing. However, we do need to worry about these y's here. So the x on the bottom is going to stay there because we said positive exponents, but it said no fractional exponents in the denominator. So we actually can't just leave that alone. What we're going to be doing is, because we can't have any only positive exponents with no fractional exponents in denominator. One pause. Okay, I paused because I thought it was a bad instruction. I thought that I think this instruction is actually just incorrect. I have the same exact program here. It's called CUDA software that makes this program. It has this rule where it says only positive exponents, no fractional exponents in the denominator. And the only way to fix the x to make that not true is to basically multiply the top and the bottom by the same thing to move it up to the top, which is called rationalizing the denominator, which I guess we do know how to do. However, it's really non-standard for fractional exponents to do it that way. But I'm just going to do this whole thing anyways. I'm just going to explain the same way I was going to, and then I'll talk about what I was going to do at the end. Either way, the x is already taken care of. It already is a positive. We'll worry about the fractional exponent in a moment. The 3's cancel just like I said. And as for the y's, you have a choice to make here. You can either take that 3 over 2 and move it to the top, or you could take this 1 and move it to the bottom. Because you want to have positive exponents, and that should be your first goal, is to make sure you have positive exponents, you should be doing the one where you move it to the bottom. That way you end up with a 1/2 on the bottom. So really what I'm talking about here is I'm doing 3 over 2 minus 1 to get myself a 1/2. Again, using my calculator if you need to do so. And that is for my y exponents. So now we are rewriting it. The 3's are gone. I have nothing left on the top. By the way, if you have nothing left on something, you want to just make it a 1 on the top. And then on the bottom, again, those 3's have canceled. You have x to the 5/3, and we have y to the 1/2. Now, personal opinion, this is going to be enough for this, but this is no fractional exponents in denominator. Anytime that's the case, you need to quote unquote, I'm just going to write this down in quotes here. I'm going to say in quote, add exponents until whole number. So what I mean by that is this would be 5 over 3 would become a whole number if I just had one more 1 over 3, because then it'd be 6 over 3, which is 2. So I'm going to add that exponent to the top side, 5 over 3. To get to a whole number, I need to add one more. So that's going to be x to the 1 over 3. As for my y, I also need to add one more, but I'm adding one more. That's a 1/2. So I'm adding that y to the 1/2. And now the bottom is that whole value. We just said we're adding 1 over 3. So 5 over 3 becomes 6 over 3, which is 2. And a 1/2 plus a 1/2 is 1. And this is our final answer. So let's think about that whole process one more time. Let's talk about it one more time. First of all, the 3's canceled. After the 3's canceled, my first goal is positive exponents. We'll worry about the fractional part later. First thing with positive exponents is I had to do the 3 over 2 minus 1. If I had done it the other way around and I'd brought the 3 over 2 to the top, then it would have been a negative on the top, which we would have had to move back down to the bottom anyways to make it positive. After that, we are adding exponents until whole. So that 5 over 3, this one right here, you had to do 5 over 3 plus 1 over 3 to get 2. You have to add it until it gets you to a whole, and that's where that 2 comes from, and that 1/3 was added on top. In terms of the mathematics, why you're allowed to do this, what you actually did from step to step was to multiply the top and the bottom by x to the 1/3. So for instance, if I'm just going to kind of write this off to the side over here, I'm just going to do just the x. If I had the 5 over 3 and I multiplied that by x to the 1/3 over x to the 1/3, by the way, you're always allowed to multiply by 1. That's what I did. I multiplied by 1. This is a fraction. This top part became x to the 1/3 and the bottom became x to the 6/3, but 6 divided by 3 is 2. So that's where this thing came from. Let's see this entire process one more time on a future question, I'm sure, but we'll still be okay. Here we go. Question number 5. So on question number 5, first of all, I think it's going to be easiest for us to add all of our exponents together first. So really what we're doing in our calculator here, I'm not going to write anything down. I'm just going to cheat with the calculator completely, showing you how I would do this if I was really doing this problem. I would have my 2 divided by 3, and I'm adding it to 1 because, again, there's that invisible 1 that's like right here. And then now we're going to be adding that to alpha y equals enter. We're going to go ahead and get, already forgot 1 over 2. Okay. So yeah, 13 over 6. So this guy right here is going to be x to the 13 over 6, and that is all raised to the negative 2/3 power. Anytime you have a power of a power, you multiply exponents. That is to say, my general rule of thumb, if I have x to the a raised to the b, that's x to the a times b. So yet again, let's just cheat and use our calculator. If you want to do these by hand, you knock yourself out. Not really part of my game plan here. So we're going to be doing 13 over 6, and then we're multiplying that by a fraction again, and we're going to end up, what's the fraction again? Negative 2 over 3. Negative 2 over 3. So it turns out that's going to be negative 13 over 9. However, we are not allowed to have negative exponents. So we're going to use one of the rules that we wrote down a little bit earlier. Anything that is a negative exponent in the numerator becomes a positive exponent in the denominator. So now it's going to be 1 over x to the 13 over 9. And just like that previous question, we need to add until a whole number. So we have to do 13 plus something to make it a whole number when you divide by 9. So if you're thinking about 9 and your multiples of 9, you should be thinking 9, 18, 27. Because 13 is in between these two, you need to get up to 18. So I need to add 5. 13 plus 5 gives me 18. 18 divided by 9 is 2. So here we go. For that one, we're adding 5 more. We got x to the 5 over 9 divided by our x to the power of 2. And there is our final answer. And like I said, this is kind of, it's not the way I remember seeing it as a kid, but that's okay. Maybe things are different now. Whatever. I'm getting old. All right, here we go. On this one. So this one, we do have our two different ones and we'd like to add them, but we can't. We have to do our power of a power first. So using our power of a power, again, you can use your calculator for these. I recommend using your calculator for these. However, because there are no, there's no canceling here, it's just going to be 21 over 8. So this is v to the 21 over 8. I did 7 times 3 to get 21, 4 times 2 to get 8. Again, use your calculator, pretty please. 4 over 3. Use your calculator to add those up. I don't feel like doing 8 times 4 and 3 times 21 and then blah, 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 blah. What are we doing? We're using our calculator. Alpha y equals enter. We have 21 over 8 plus alpha y equals enter 4 over 3. And wow, what an answer. V to the 95 divided by 24. What a gorgeous answer. We definitely like the 95 divided by 24. There's no sarcasm whatsoever here. All right, continuing on. We have this one. So we could do the 1/4 first, but again, we like to add first. 1/2 plus -1. You probably should be able to do that by now in our head. -1/2 times y to the 5 over 3. And then this is to the power of 1/4. When you are multiplying your exponents, so you power over power, you multiply exponents. We're going to multiply. This is going to be x to the -1 over 8 multiplied by y to the 5 over 12. That y to the 5/12 is fine. That's a fractional exponent in the numerator. However, the negative 1 over 8, by the way, that's what that is, 1 over 8. Sorry about that. Our x to the negative 1 over 8 can't do that. We have to write it into the denominator. So 5 over 12 to the divided by 1 over 8. Just like we were talking about before, we have to add up to a whole number. In this case, it's nice and easy. We just have to add 7 to get up to 8. So we have x to the 7 over 8, y to the 5 over 12, divided by x to the power of 1. Let's keep on moving here. Going on to this next one. This one's actually kind of nice because the -2 and the +2 cancel out because it becomes 0, and anything to the 0 power is just 1, besides 0, of course, but maybe some other situations, whatever. -2 plus 2 is 0, so we don't have it. So instead we have x to the 3 over 2 raised to the power of -2 over 3. And this is kind of interesting because the 2's cancel and the 3's cancel when you actually multiply your fractions. So you get x to the -1, which we will rewrite as x to the 1 over x, or 1 over x to the 1. Keeping the ball rolling here, we have m to the 2/3 divided by this thing. Just like that last time when we had these two different ones, we're just going to copy that top value while we deal with the bottom here. Power over power, you multiply exponents. So 3 times 1 is 3. 4 times 4 is 16. And now we have to make the decision. Do we move the 2/3 to the bottom or the 3/16 to the top? I think it's pretty clear you want to move fractional exponents out of the denominator in general. So in this case, we're going to be doing that 2/3 minus 3/16, but we are using our calculator to do so because we are lazy. So here we go. We have 2/3 minus the alpha y equals enter. 3, I already forgot. Is 3/16? I can't read my own handwriting. 3, oh my gosh. 43/48. Oh yeah, or 23/48. What a beautiful answer. Oh my gosh, can't even write. M to the 23 divided by 48. Okay, sure. Yeah, everyone likes answers like that. Here we go. This one's easy. It's 1 because -7/4, -7/4, n to that power, it's going to cancel out, become 1. 1 squared is 1, so we're done. That was a freebie. Nice to have one nice, easy question. Let's turn this page over. So we got a double here. We have that -2. We got to deal with it, but we have to deal with that exponent at the bottom, power over power, you have to deal with first. So -1/2 to the second, -1/2 times 2 is just -1. Just like we were talking about before, we now need to make a decision. Are we going to move that -1 to the top or the -2 to the bottom? Because we want positive numbers in our end, we're going to move the -2 to the bottom, become a +2. -1 plus 2 is +1. You get x divided by y. And again, if you're somebody who needs to hear what happened there, what we really did there was y to the -1 times y to the +2. Like we did this. And that's where the adding came in, -1 plus 2. Anyways, continue on. Number 12. All right. On this one, just like that last problem, we're going to apply our power of a power rule first. We're going to multiply those exponents. 2 times -1 is -2. 2 times 1/4 is 1/2. Again, use your calculator if you are struggling with any aspect of that. We need to get those negatives out of the denominator, so we're going to move that 2 up to the top. Anytime you're adding a whole number, all you're doing is adding multiples of the denominator. So when I'm doing 5/3 plus 2, it's like 5/3 plus 6/3. So I'm adding that 6, 2 times 3. So 5 plus 6 is 11. So we're going to already have that version of the answer. I guess I'll have to get my face out of the way here. Equal to x to, I already forgot, 11/3. Divided by y to the 1/2. However, we had just learned earlier that we're not allowed to have fractional exponents, and we're going to quote unquote add numbers until you get to a whole number. We need to add one more number to that 1/2. So we're going to have x to the 11/3 multiplied by y to the 1/2 divided by y to the 1. There it is. That's an 11 divided by 3, by the way. My handwriting is leaving a lot to be desired on this assignment here. I'm trying, guys. You might need to listen to what I'm saying instead of looking what I'm writing down. Oh boy. All right, over here. Just like we said before, got to apply those power rules first. So we have b to the -6/4, which is the same thing as -3/2, divided by, and this time we're adding those exponents together. 1 plus 1/2 is 3/2. No negative exponents allowed, so we're going to move that negative to the bottom. It becomes a positive, and in this case, it's actually really nice because the fractions disappear. So -3/2 becomes +3/2. 3/2 plus 3/2 is 6/2. 6/2 is 3. Over here, we got x all the way. So we have x to the -1/4 power. You multiply exponents. Over here, we're adding 1 plus 5/3. Anytime you're adding a whole number, you add multiples of the denominator. We're adding one denominator. 5 plus 3 is 8. X to the 8 divided by 3. We are not allowed to have negative exponents, so we deal with the negative exponents first. After dealing with those negative exponents, we bring it to the bottom. It becomes 1 over, and we are using our calculator to do 8/3 plus 1/4, because that negative becomes a positive. So alpha y equals enter for me, 8 divided by 3, and then plus 1 divided by 4. Oops. Well, I bet you it'll still work if I did it this way. No, I lied to you guys. What do you know? Mr. Richard lying. Hilarious. All right, there's my 1/4. Here it is, 35/12. x to the 35 over 12. And we have to figure out we're adding numbers to get up to a whole number. So how many more numbers do I need to add to 35 to get a multiple of 12? Well, 36 is a multiple of 12 because 3 times 6. So we only need to add one more. So x to the 1 divided by 12. And then now on the bottom, it's a 3. Let's go ahead and move on to question number 15. So question number 15, just like we were talking about before, we have to deal with those power of a power first. So this is such a long one to write out, and especially the one below this, it looks like nasty to write out. So I'm going to be lazy with this. And instead of writing out like every single little tiny step, I'm just going to be writing like just this part here is x to the 1/2 y to the -3 over 4. And then now we're going to try to like combine everything into the numerator or denominator right away, because there's just too many things to write down and I don't want to like lose my work and get caught up in it and I can't figure out what's going on. I can't do this, can't do that. So what's going to happen is I'm going to write an X list and I'm going to write a Y list. You don't have to do this on these problems, but it makes it easy for me. So we're just going to go ahead and first we're going to move everything to the numerator. We're not going to worry about any negative exponent nonsense at the start here. So we're going to have -1 plus 1/2 minus 3 over 2, because I took that -1, I added it to that 1/2, and then I have this 3 over 2, but I'm putting it in the numerator so I don't have to worry about it. And then for the y, I'm going to have a -1 plus a -3 over 4 plus a 1/2. And we are just going to now use our calculator to do these additions for us. So -1 plus 1 over 2 minus 3 over 2. And we get -2 for this x value. And for the y, we're getting -1 plus -3. I'm going to show you another way, by the way, just because I already forgot and messed it up. So it's going to give you a decimal answer. Anytime it gives you a decimal answer, you can always hit math enter. It will convert it to a fraction for you. So -5 over 4. So basically what we're trying to say is this entire thing is x to the -2, y to the -5 over 4. We are not allowed to have negative exponents at all. So we rewrite it immediately as 1 over x to the power 2, y to the 5 over 4. No fractional exponents in denominator. We're going to add numbers to that bottom fraction to make it into a whole number. So a multiple of 4 would be 8. 5 plus 3 is 8. So our final answer to this question is y to the 3/4 divided by x squared y squared. And I'll repeat one more time just in case you're confused where the y squared came from. We figured out that I had to add 3 more to get the 8. 8 divided by 4 is 2. Okay. Same exact idea on this one. So -1 is going to make both of these positive. So I'm just going to kind of like, that's a plus now. That's a minus. That's a plus. Okay, here's my x list. I have a 2 plus 3 over 2 plus 1. The 2, 3 over 2, and the 1. And the y's, we have 3 plus -1/2 because that's a negative now. And then, oh, it's -1. Geez, Mr. Richards. -1 because you're in denominator there. And then -1 over 3. Okay. So anyways, 2 minus 1 is 1, and 1 plus 3 over 2 is in fact 5 over 2, and 3 minus 5/6 is going to go ahead. You can do these in your head too if you really wanted to, by the way. It's not out of the realm of possibility. You get 13 over, I lied, not 13. No, it is 13. 13 over 6. Okay. Just to prove to you, because now after I make a mistake like that, I like want to double check. I'm sure you guys do the same thing at some point in time. Maybe yours are slightly less obnoxious. Anyways, 13 over 6. So those are all positive, so don't have to worry about it. They're all positive. There's no fractional exponents in the denominator, and we're done. You can't even see what I wrote, but that's our answer. Yeah. Last two problems. Here we go. Geez Louise. All right, so we're going to have to do everything all done, and then we're going to have to raise it to the 5/3 at the end. Dude, there's so many numbers here. I don't even want to do it, but we're just gonna get it done. Here we go. Here we go. Power of a power, you multiply exponents, and that's what we're gonna do. We're gonna multiply this 5/3 to this -7/4 to that -2 to that n, and we're gonna do the same thing we did in that previous question with the n's, and the p's. We're gonna keep them separated, and then we're gonna combine them at the end because it'll be easier to write down all of our work for it. So we have our n, we have our m's, and we have our p's. Remember, everything at the end is going to get raised to that 5/3 at the end. We'll do that as our very, very last step. So n to the 5/3 is just going to be 5/3 as it is. Let's see other n's that we're going to have to deal with. And then we're going to have to do -3/4. We did minus on this one because it was in the denominator. And on this one, we're going to get +3/2 because it was in the denominator. And don't forget, all of this at the end is going to get multiplied by that 5/3. Now for this letter M, what are we going to do? We're going to do the same exact process. We have the -2 times the 5/3. So that is -10/3. And now the next letter M here, we have -2/3, but it's really a +2/3 because it was in the denominator. And then that -2 becomes a +2. And again, all that multiplied by 5/3. Now we have to set up for these letter P's. We have a -7/4 times 5/3. -7 times 5 is -35. On the bottom there, 4 times 3 is 12. And then now we have to add that. We're doing letter P. 3/2 is -3/2 now. Should have done -3/2, whatever. And then this letter P here is a +2, so now it is a -2, so plus a -2 if you wanted to. And again, all this is times 5/3. We are using our calculator to our maximum advantage here. I'm going to use the answer to fraction button because it's going to be faster on this old calculator, but your alpha X button might be faster on this calculator. I don't know, whatever. -3 divided by 4 plus 3 divided by 2, and those parentheses times 5 divided by 3, and then math, enter, and okay. And then how about this next one? -10 divided by 3 plus 2 divided by 3 plus 2, and the parentheses times 5 divided by 3. Okay. And that's at least a little bit better. All right, and then our last one here, a nice -35 divided by 12 plus -3 divided by 2 minus 2, and the parentheses times 5 divided by 3. Math, enter. Okay. All right. So we are going to have one part of our answer done. This n is going to be good to go, but this one is going to end up being a 10/9 in the denominator. So like it's going to be a positive 10/9 in the denominator because it's going to be a 10/9 in the denominator. We're going to it's going to end up being like a 1 over m to the 10/9, just like that. Other problems that we have to get it so it's a total of a whole number, a multiple of the bottom. Multiples of 9 would be 18. 10 plus 8 is going to give us 18. So this one right here really is going to end up being m to the 8/9, and then m to the power of 2 on the bottom. And on this one, man, oh man, I really don't know my multiples of 36 all the way to freaking 396, apparently. Look at me, I did know it. Look at that. Anyways, this one is going to be 1 over that number. So like this is like 1 over m to the 385 divided by 36. And like we were just saying, you need to get to a whole number. The way I did that in my head, by the way, 360 is clearly a multiple of 36. 360 plus 36, 396. 396 minus 385 is 11. Holy Toledo. What a question. m to the 11 over 36 divided by 36 was 10, 360 was 10, 396 would be 11, so m to the 11th. Final answer, we're finally ready to write everything down. Our n is our only easy one. We have n to the power of 145 divided by 36, and that is going to be multiplied by m to the 8 divided by 9, and that is going to be multiplied by by it's letter P, guys. How come no one corrected me? Oh, yeah, because I'm by myself in my room. P to the power of 11 over 36 divided by m squared times p to the 11th. Didn't know I could hate a math problem this much. But I can. Here we go. We're on the last problem finally. Number 18. What did I agree to here? We're already at a 30-minute video and we haven't even finished yet. So on this one here, I'm doing the same exact thing as I did in that last question. We're going to write an X. We're going to write a Y. We're going to write a Z. We're going to keep all of these separated to the best of our ability using our exponent rules as needed. Our X has a 1/2 on the top, and then you're going to be subtracting because it's on the denominator. And then you have a 2 to the power of 4. So it's really like 2 times 4. We're going to just write it all the way out. 2 times 4. And then again, you are subtracting, and I'm going to use parentheses here, but we have -1 times 1/2. So -1 times -1/2. You don't really need to write all that out. You could have written like, -1 times whatever. You get the point. Well, maybe you do. Who knows? All right. Anyways, you have a 2. And then after that, yet again, instead of writing it all out, like I was saying, though, if you just did -1 times 4, you get -4, but negative on the bottom is adding. So like +4. This is a fast way to do this question. And then after that, our next y value is this one. And this is going to be 3 over 2 times -1/2. But moving to the top, it's like +1/2. So plus 3 over 2 times 1 over 2. I guess you could have written out the work for it. And then now we have -3 over 2 on the Z. Negative becomes a positive, plus 7 over 4 times 4. The 4s are going to cancel, so you're going to get just +7. And again, it's a positive because the negative becomes a positive to the top. And then the Z, 2 over 3 times 1 over 2, positive because it's moving to the top. 2's cancel, you get a third. So plus a third. And yeah, we're using a calculator. We are using a calculator. 1 divided by 2, -8, and then -1/2. Oh, actually, isn't that just 8? Negative, well, okay, well, -8, duh. Negative times a negative is a positive minus the same numbers at back, so that's why you just have that -8 on the x value. By the way, that's going to end up becoming a 1 over x to the power of 8 for our answer there. Negative becomes a positive in denominator. And then over here, we're going to get 2 plus 4 plus, looks like 3 divided by 4. And again, this is one we could have probably just done without a calculator, but that's okay. 27 over 4. That's all numerator, so we have nothing to worry about. That's going to become y to the 27 divided by 4. And then for this last one, -3 over 2 plus 7 plus a third. And that's going to hit... and that's going to be 35 over 6. And again, that is all positive. So there's no extra work we have to do in this question. How exciting. Our final answer, we're going to have a y to the 27 over 4 multiplied by our z to the 35 over 6, and then divided by x to the power of 8. You couldn't even see my x there at the bottom. Whatever. I'm done with this stuff. You're probably done too. Peace out. Have a great rest of your day.